Alright, in this video we're going over transforming polynomial functions part 1. Our LEQ is how do you apply transformations to graphs of polynomials. Alright, so transforming y equals x cubed. So what is an equation of the graph of y equals x cubed under a vertical compression by a factor of 1/2, followed by a reflection across the x-axis, a horizontal translation 3 units to the right, and then a vertical translations 2 units up. All right, so it seems like a lot to do, but let's attack it one step at a time. So let's first tackle the vertical compression by a factor of 1/2. Well, if you remember back to our transformations unit, a vertical compression of a factor of 1/2, you just take your function and multiply it by 1/2. So step 1, we're going to multiply by 1/2 to compress. So we're going to have y equals x cubed, and we're going to simply multiply that by 1/2. So we're going to have y equals 1/2 x cubed. So now this is our new function. So let's look at step 2, followed by a reflection across the x-axis. So for that, we're simply going to multiply by -1 to reflect. Because if you remember, when you multiply by -1, you flip your graph, or you flip your function across the x-axis when you multiply the whole thing by -1. So that's why we multiplied by -1 to reflect across the x. Then it's a horizontal translation 3 units to the right. So since that's horizontal, if you remember back, horizontal translations directly affect the x. In order to directly affect the x, we're going to have x, and since it's to the right, it's going to be minus. It's going to have to be x minus 3. So we're going to subtract 3 from x, or you can replace x with x minus 3 to translate it horizontally. Okay? Because remember, x minus 3, it goes to the right. X plus 3, it goes to the left. And again, the minus 3 has to be inside the parentheses with the x to translate it horizontally. And then finally, a vertical translation 2 units up. So with that, you just throw a +2 on the end. Because with verticals, plus goes up, negative goes down. Okay? So this is exactly like transforming regular functions like we were doing before. Okay, when we were doing it with quadratics, it works the same way. A compression, you multiply by a fraction. A stretch, you multiply by a number greater than 1. To reflect across the x, you multiply the whole thing by -1. Horizontal translations, you add or subtract directly to the x, like we did here. We're subtracting directly with the x. And vertical translations, you add or subtract to the entire function. All right. So let's see how well you can remember translations. What is an equation of the graph of y equals x cubed under a vertical stretch by the factor 2, followed by a translation 3 units to the left, and then a vertical translation 4 units down? So tackle this one part at a time. Pause the video and see if you can get this one right. All right. So we have our function y, oops, select a pen, y equals x cubed. So the first thing we're going to do, let's stretch it by a factor of 2. So we're going to multiply by 2. So we're going to have y equals 2x cubed. So that's step 1. Now we're going to start with our 2x cubed because that's our new function. All right, and now it's a horizontal translation 3 units to the left. So we know we're going to be dealing directly with the x. So we're going to have some parentheses here. So y equals 2 parentheses, and we know it's still cubed. It's 3 units to the left. Going to the left, remember, is a positive. So it's x plus 3. All right, so this was our stretch. This was our translations 3 units to the left. So now let's start with this function. And we're going to translate that vertically 4 units down. So to do a vertical translation 4 units down, you're simply going to subtract 4 from the entire function. Okay? So this is what you should have ended up with right there. So these are a lot easier if you just take them step by step. So vertical stretch by factor 2, you take it, you multiply it by 2. Then you start there. Horizontal translation 3 units to the left. Remember, horizontal translations, you got to directly affect the x. So and to the left, it's a plus 3. So parentheses x plus 3, you're directly affecting the x. You still have your 2, and you still have your cubed. So now you start with that one, and then it says a vertical translation 4 units down. So you take that, and for a vertical translation, you add or subtract directly to it. Since we're going 4 units down, we're subtracting 4 from the whole thing. All right? That's pretty much all there is to that. All right, finding the zeros of a transformed cubic function. And of course, this is going to be multiple choice. So we're going to figure out what the answer is. If a, h, and k are real numbers, and a is not 0, because if a is 0, you just have k. And this whole example is pointless. How many distinct, meaning if you have multiple zeros, you only count it one time. How many distinct real zeros does y equals negative a parentheses x minus h cubed plus k have? So remember, when you're trying to find a 0, the first thing you have to do is set your function equal to 0. That's the very first thing you have to do. All right, is set your function equal to 0. Then we want to start solving for x. So the next thing, we're going to subtract k from each side. So we're going to get k, we're going to move it over here. So it's a plus, so we subtracted it. Now the next thing we need to do to get x, because we're trying to get x by itself, so the next thing we need to do is get rid of this a. So since it's multiplied, it's a negative a times, we're going to divide by negative a. So we're going to divide each side by negative a, gets rid of it on this side, and it also gets rid of the negative sign on this side because negative divided by negative is positive. So x minus h cubed equals k over a. Now, the next thing we need to do, since this is cubed and we want x, and x is involved with the cubed, we have to take the cubed root of both sides. So taking the cubed root of this side nullifies the cube, leaving you with just x minus h. Then of course you have the cubed root of this side, cubed root of k over a. So now, again, we want x by itself, so the next thing we have to do is add h to both sides to finally solve for x. All right, make sure you're writing this process down. So x equals the cubed root of k over a plus h. Okay, and of course, when you take the cubed root, you don't have multiple answers, you only have one. It's not like the square root or any even-powered root. You always have two answers because you have the positive and the negative of whatever number you got. Cubed roots or odd-powered roots, you only end up with one answer. So if this is one number plus another number, you're going to have only one distinct real zero. So disregarding multiplicities, meaning multiple zeros, the function has a single zero, so the correct answer is B. This function only has one zero, meaning this function only crosses one time. Okay? This function only crosses one time. Now make sure you wrote that down because the example with numbers I'm going to have you do is the got it. It follows the same exact process. So hopefully you wrote down the previous slide. If not, rewind the video and write it down. And then solve this one out. What are all the real zeros of the function y equals 3, quantity x minus 1 cubed plus 6? So pause the video and figure it out. All right, so step 1 is always set it equal to 0. So we have 3x minus 1 cubed plus 6 equals 0. Now, we got to get x by itself. So the first thing we need to do, subtract 6 to get it over here. So 3x minus 1 cubed equals negative 6. Now, again, we're still trying to get x minus 1 by itself. So our next step is to get rid of the 3. So we're going to divide both sides by 3. So x minus 1 cubed equals negative 2, because negative 6 divided by 3 is negative 2. Now our next step in solving for x is we got to get rid of the cubed. So we take the cubed root of both sides. So the cubed root nullifies the cube. So now we just have x minus 1 equals the cubed root of negative 2. And now, of course, we can just simply add the 1 to the other side. So we get x equals 1 plus the cubed root of negative 2. Now, we can't take the cubed root of negative 2 because it's an irrational number, so we might as well just leave it in the cubed root. But what we can do is we can pull out this negative, because you could rewrite this as negative 1 times 2, and the cubed root of negative 1 is, of course, negative 1. Okay? So the proper way to write this is when you have a negative under here, and you have an odd-powered exponent right there, the proper thing to do is pull out the negative, so our answer would actually look like 1 minus the cubed root of 2. Yes, they're both mathematically equivalent, but writing it as 1 minus the cubed root of the square of, 1 minus the cubed root of 2 is the standard way to write it. It's the more accepted way to write it. So please make sure when you're taking the cubed root of a negative number, go ahead and pull out the negative, so that way you only have a positive number under the root sign. Okay? All right, so that's been your transforming polynomial functions, the first part of the video. The second part you're going to watch tomorrow night. Feel free to watch this video as many times as you need to. Make sure you understand the concepts, make sure you've taken notes, and make sure you come to class tomorrow ready to work some problems. See you tomorrow.